Hello students, myself Anmoljan, Assistant Professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Today I am going to discuss the next experiment, that is designing data path using multiplexer, right? So the objective of today's class is that how we can design a data path for data transfer for 4 registers of 4-bit using multiplexers. So before moving to the uh, practical implementation, we have to answer the following questions. Number one, number of multiplexers required. So the answer is the number of multiplexers is equals to number of bits in registers. So the number of multiplexers required can be identified with the number of bits in registers. So what is the size of the register? That is 4 bit. So answer will be 4. That 4 multiplexers are required. Second thing is that what should be the size of that multiplexer. So size of the multiplexer that can be determined with the number of registers into 1. So number of registers are 4. So size of each register will be the 4 cross 1. Right? Next question is asked that number of selection keys is required in multiplexer. So if the number of inputs is 4, then number of keys can be determined with this formula, that is log base 2 number of input, that is log base 2 and 4, that is 2, right? So 2 selection keys are required for it. So let's see that how we can design this data path using set of multiplexer. So just we move to the Logisim software which we have. So first step, we should have 4 registers. So the registers are found within the memory. So I take 4 registers, 1, and each register set of 4 bit. So I make it of 4 bit, right? Then input bits, so the input should be of 4 bit. I make it 4 bit, then an output, right? Then there must be a clock also. So we will make this clock also, right? So we need 4 such type of combination, that is Control C, Control V. 4 registers, and each register of 4 bit, right? To just arrange them, then we need 4 multiplexers, and each multiplexer is having 2 selection keys. Right? So number of selection keys should be enabled now. Number of selection keys are common to each multiplexer, and the number of selection keys are 2. Set its direction as north, and make use of 2 bits. Right. So now I am ready with the 4 multiplexers of 4 cross 1 size and 4 registers of 4 bit. Right. So now my objective is that if the selection keys are 0 0, then the register R1 should be selected, or the R0 register should be selected. When it is 0 1, R1 should be selected. When 1 0, R2 should be selected, and when it is 1 1, R3 should be selected. Right. That means when this is 0 0, now my register, suppose this is my R0. R1, 2, R3, right? R1, R2, and this is your R3. So now my objective is when this is 0 0, then R0 should be selected. So the concept is when this is 0 0, when this is 0 0, then the 0th input of this multiplexer will be enabled, right? Right? And the 0th input of this multiplexer will be enabled. Similarly of the next, and similarly for the last. So how this first bit will be transferred to it? Let me use one splitter for it purpose. Just I will show you one example. That is a 4-bit fan in fan out are a 4-bit. So this 0 bit should go in this multiplexer, and this will be your output. Then the first bit of this register 1 should pass through the 0th input of the next register. Right? And the second bit should pass through the 0th input of the next multiplexer. So what you see here, that all the 0th, first, second, third bit has been transferred to other location or the other register. Right? So what is the logic? When this is 0 0, then the 0th input of this multiplexer, 0th input of the next multiplexer, 0th of the next multiplexer, 0th input of the last multiplexer will 1. So when it is 0 0, all the bits of R0 has been transferred to another place. Right? So now this transfer can be done from one register to another register. So if I change the value of register here, then the output should be changed. No, so it is not changed. What is wrong? I have to add one more clock, that all register must be synchronized with the clock. So I make it enable with the clock. It should be enable. So how we can make it enable? Go to the simulate, take once, take enabled, set frequency. So once the clock is okay, then you see that the data has been transferred 0100, that is 0100, right? Now similarly and so on, we can make a connection for this one, that is R1 register. Now how the 4 bit can be transferred? So this register should be selected when the value of selection keys are 0 1. When this 0 1, at that moment the first input of this multiplexer will work, first input of this multiplexer will work, and so on. So now my objective is just pass the each bit of this multiplexer second input, sorry, first input pass through the first input of second input, second bit the first, next this is the second, the next input of the next multiplex, and last it should pass through the next. So what you see here, all the bit of register R1 has been transferred. Now let's see if the register R1 is 1 1 1 1. So all the bits have been transferred here, right? So in this way we can transfer the data of register to different location. So these bits can be transferred into a register. So how we can transfer these bits into a register? Again, we can use a splitter in an opposite direction. This is my west of 4 bits, right? So this is my 0th bit. So I can merge them into next location. right? And put them into a register. Again, I take a register will be get into memory. Make a register of 4 bits only, right? So the data has been transferred to this register. Let me see the register is having 4 bits or not. Make it a 4 bit, right? So when this is 0 1, all the bit has been transferred to register R5. So it is not there. That is all 1 should come here. 1, so something went wrong. Let me check. Okay, this is not synchronized with the clock. So make it synchronized with the clock also. Right? So the data has been transferred from register R1 to R5. So in this way we can transfer the data from any register to any register. Right? Thank you.